Hello, geometry students. We are moving on to section 7-7, which deals with scale drawings and models. Chapter 7 has been all about proportions and ratios, and we're going to focus on scale models today. A scale model or a scale drawing is an object or drawing with lengths proportional to the object it represents. And so you've probably seen models before, models of buildings, maps, those kinds of things have scale drawings to them. And the scale of a model or a drawing is the ratio of the length on the model or the drawing to the actual. So you're going to take the length of the model over the actual model. Let's look at our examples. The scale on the map shown is 75/100ths of an inch to 6 miles. Find the actual distance between the two cities. And I've already measured between those two cities, and I'm getting 1 25/100ths of an inch. And so they give me my scale, 75/100ths of an inch over 6 miles. And now I'm looking for how many miles it is. So I'm setting up a proportion. Because I'm looking for how far it is, I'm looking for my miles, so I'm going to have my X be on the bottom. I use the labels here to help me know what number belongs where. In my scale, 0.75 inches, so across from that I'm going to use 1 25/100ths of an inch. At that point, you guys just say, go ahead and cross multiply. I'm getting 7.75 times X, 6 times 1 25/100ths. Cross multiplying. Go ahead and multiply. 6 and 1 25/100ths is 7 5/10. Go ahead and divide. X ends up equaling 10. Now, I'm running out of room here, people want to move down, but when we do word problems, we really need to just not have X equals 10, but we need to say, what does X represent? It represents the actual distance is 10 miles. And some of you guys are getting really good at this. You're writing the sentences. Others still need some work with that. So don't just write 10 and box it in, but I need to have a sentence. I need to know, what does your 10 really represent? Let's move on to our next problem. A dollhouse that is 15 inches tall is a scale model of a real house that has a height of 20 feet. So you take your scale model drawing, which is 15 inches, and then you take it over your actual, which is 20 feet. Now you can go ahead and reduce that, people. Divide everything by 5. So 3 inches over 4 feet is that scale. In letter B, we want to know how many times as tall as the actual house as is the model. So I'm looking for how many times bigger is the actual house in comparison to the model. So I need to now be looking at, I got 3 inches over 4 feet. Well, you can't compare if you don't have the same label. So they need to have the same label here. So I need this feet to be inches, is what I'm saying to you. So I need to multiply by a conversion. So I'm going to multiply here. I do not want these feet. I don't want the feet on the bottom. So I'm going to write a feet on top so I can cancel. My goal is to get inches on the bottom, so I'm going to put inches here. What is the relationship from feet to inches? Now, 1 foot is 12 inches. Now, the reason why you put the feet on the top is so that you get rid of the label for feet on the bottom, so those cancel out. Now, we also have to, we can punch this in our calculator, but we should use our powerful minds here and reduce our 3. 3 divided by 3 gives me 1, and 12 divided by 3 gives me 4. So don't use your calculators, people. Now, when I multiply across, I'm getting 1 inch. When I multiply across on the bottom, I'm getting 16 inches. And so those labels can cancel too. So the new model here, the model is 1/16 of the original. And again, don't just write 1/16 down. You need to write a sentence here. Let me know what you're talking about, people. Let's move on to our last problem, architecture. An architect is making a scale model of an office building he wishes to construct. The model is 9 inches tall. The actual office building he plans to construct will be 75 feet tall. And so again, we're asking for the scale of the model. So you're going to take the model, which is 9 inches, over the original, which is 75 feet. And again, you guys are going to reduce that. So I'm dividing everything by 3 here. And so I'm going to get 3 inches, and I'm going to get 25 feet. Letter B says, what scale factor did the architect use to build his model? And so I need to take my scale factor, which is 3 inches over 25 feet, and I need to have the same labels again. I've got inches and feet, so I really want this feet here. I need that in inches. So I'm going to multiply by a conversion factor. I'm going to multiply by a ratio. I don't want these feet on the bottom, so I'm going to write feet on the top. My goal is I'd like to have a comparison with inches to inches. So I'd like inches on the bottom. 1 foot is 12 inches, so we're doing basically what we did in the last problem now. Again, my feet are going to cancel. My inches actually cancel. I didn't do that last problem. I'm going to cancel them ahead of time. And so now again, guys, take a look at the numbers. Don't just go ahead and punch this in your calculator. The 3 and the 12 also can cancel. 3 divided by 3 is 1, and 12 divided by 3 is 4. Going across, you got 1 times 1, so you got 1 on the top. Multiplying across on the bottom, you got 25 times 4. You got 1/100. So what scale factor did the architect use to build his model? The scale factor used to build the model was 1/100. And again, guys, students, please don't just write 1/100, but please write a sentence, communicate what that means. The reader should not have to go, okay, 1/100, what does that mean? So let's start making sure that we're writing those sentences out. I'll be looking for that in your homework assignment. And as we move into the next chapter, we're going to have a number of word problems, and that will be a real emphasis, is writing those sentences out. So thank you. You guys have a great night, and I'll see you tomorrow in class.